That light here from behind us again. 3,000 kilometers an hour. The shadow is raced away across the North Atlantic now. We're back in daylight. That is almost as spectacular as the light reappearing. Because suddenly we were in pitch black and it raced across, and as we can feel now, it's getting brighter and brighter by the second to the end. But the darkness, wasn't it? Totally dark. Yes. I couldn't see anything, barely see you, and it was a plunged, complete darkness. But again, easy to forget that it was this column of darkness stretching 240,000 miles up to the moon that we were standing in. A very precious thing to have experienced. Your first run, how did you feel? First one, spectacular, worth the wait. We didn't need a clear sky to feel the, I suppose, awe-inspiring experience of that vacuum light.
That's an excellent way of putting it, isn't it? A column of darkness extending from the moon, like a finger going across, and just you pass underneath it. You have to look.
Yeah, and I think that's what Chris Riley said earlier. That feeling that I felt what he felt, which is that you see astronomy in action. It's very unusual, but when it's daylight or even when it's the night, you don't get the sense, I think, that you've stood on a planet. But an eclipse, I think, is the one moment when you feel that you're on a ball of rock.
You feel the clockwork universe spinning around.
Yeah,
how it all links together.
See how fast everything moves as well.
We can look back over some of the highlights of the eclipse, in particular the baby's beads.
Yeah, no, they were bright. Liz remarks on this as well, the brightness of the Bailey's beads. And you see how fast the moon's moving. You usually don't get that sense of how quick everything's moving around. But there you saw the Bailey's beads momentary, not much of a diamond ring actually on the way in.
No, but she mentioned anything of prominence. She said that she's spotted. What is prominence?
Well, prominence, so these are eruptions from the sun's surface. Now, we know that the sun is extremely active at the moment. The solar winds are lashing the earth. These are charged particles from the sun bouncing onto our atmosphere.
This is why, for example, we're seeing the northern lights at the moment.
Yes.
As far south as Yorkshire or Northumberland, we've been getting photographs of the northern light. So it's a wonderful time to see the corona.
Oh, it is, yes. We expect, you never know, of course. You never quite know. So, but you see there the beautiful glowing atmosphere. As I said, one of the great mysteries in science is how precisely that works. You've got a surface at 6,000 degrees, and then you move away from the surface, away from the source of heat, and the atmosphere gets hotter. So you're seeing plasma there, sort of gas, glowing at 500,000 degrees, whereas the surface is only 6,000. So you see on the top left there, about 10 o'clock, that Liz commented on it. We'll analyse that later. We'll get the experts to take a look. But it does look like that's an eruption from the surface of the sun. Very bright indeed, very unusual.
And would we see eruptions in the sun there that we would then later see as northern lights? I mean, what's the...
Well, yeah, it takes a few hours delay, so that one obviously seems to be pointed away from us. It's when one pointed towards us that we get these very violent auroral displays. And if you get a big one, a big solar flare, then it can take out communication satellites. It can even damage power grids and cause power cuts.
Now let's have a look at the re-emergence of some of the second diamond ring.
Now this I thought
as well. We're seeing a particular part of the spectrum here which shows more detail.
Yes, I think this is with what's called a hydrogen alpha filter on. So you're looking at the light from hydrogen atoms. The sun is predominantly hydrogen in the atmosphere. But there you see the diamond ring. It was a big one this time. I don't know if anyone expected that actually. You can never quite tell. It depends on the precise alignment and the precise geography of the moon.
That was spectacular. That was incredible. So let's get back onto the stargazing thing. Liz, it's not quite over for you yet, is it?
Hi guys, the moon shadow is speeding over our planet at the speed of 2,000, I should say, miles per hour. We're flying at about 335 miles per hour. We can't keep up with it, so...
That means we've lost Liz. You know, that's awful, but at least you know, this is technically incredibly difficult to do. With the best will in the world to Liz, I'm glad we lost her there rather than about 5 minutes ago. Yeah.
The stargazing look.
I know. We're very blessed. That was totality. But the eclipse will continue until about 10:47. You've still got an hour to catch sight. We know investment, but they've been looking at the effects of the weather. Let's go back to Leo Valera to see how they're getting on.
Hello guys, we're loving what we've been doing today, and we've been busy, haven't we, trying to find out how the weather is affected by the eclipse. It's all still going on, by the way. Let's just grab a quick word with Peter. Any early findings so far? No,
Leah, it's been fantastic. And to be honest, you didn't need a thermometer, did you, to just feel that change? The warmth just coming back from the sun again now as the data has been piling in from over 200 schools, concentrating on making that safe, getting it all together. We've been analysing that, should have some results certainly for the programme later this evening. But it's just been an amazing experience.
It really has. Thank you so much, Peter. We also we launched a balloon earlier this morning. We weren't able to get those live pictures, but Dave is here to tell us that there are other balloons out there that are sending live pictures. How does it all work? How are we able to see that?
Yeah, what we have is a computer on the payload.